Hello everyone, I'm Hetherington, a GIS consultant at Esri UK, and today we'll be looking at how to see your data differently with ArcGIS scenes. Understand the context of your data to gain insight. Sometimes viewing our 2D data in a 3D scene can help us understand the situation better and lets us interact with the data more easily. In today's example, we will be looking at flood risk on the Somerset levels. The possibility to view our data in a 3D scene really gives us a better understanding of the surrounding landscape. Secondly, I will also show you how to grab your audience's attention by converting your 2D data into a 3D visualization. We will look at doing this on ArcGIS Pro with earthquake magnitudes, as well as taking it to the next level with a 3D hex bin in an online scene. So everyone, let's get started. Here I have my ArcGIS Pro project set up, and we'll be taking a look at the Somerset levels to start with. So I have my data on the left-hand side that I pulled from ArcGIS Portal. The risk of flooding layer is from the Environment Agency. So I'm going to go ahead and turn that on. And as you can see, it shows the areas that are likely to flood. And I've clipped all of this data specifically to Somerset. So you can see that we have high, medium, low, and very low areas. And we can see that there's quite a big portion of Somerset is at risk of flooding, and we really want to understand why that is. So I'm going to turn on the rivers, and this gives us a bit more context. So we can see that there's a few rivers here that are very susceptible to flooding and the area surrounding them, whereas we have a few rivers to the west where that's not the case. So to understand this better, we may want to take a look at the topology and kind of understand why this is happening. So I'm going to go ahead and turn on the contours layer. So if you're used to reading topographical maps, we can see that there's definitely a lot going on here, and there's a lot of hills to the west. But if you don't read topographic maps often, or you don't feel confident with contours, it can be really difficult to get a picture and visualize what you're actually seeing just in a 2D surface. If you're not used to it, then this can be really challenging and doesn't provide too much more context or give much insight. And this is where pulling our data into a 3D scene can be really useful. So if we press Insert, New Map, and then New Local Scene, we'll create a 3D scene. So here's one I have earlier, and I've pulled the layers that we were using in before into this. And specifically, we don't need to build them in 3D, so we can keep them as a 2D layer. And we can pan around now and have a look, but because we're looking at such a large area, we can see a little bit of the hills, but it's not that useful to us. So we really want to see the hills and the topology more prominent. So if we click ground on elevation surfaces and then press appearance, we can actually change the vertical exaggeration. So this will just exaggerate the topology. So if we change that to 5 and let that load, and now that this is loaded, we can start interrogating it. So if we now zoom in and pan around like we did before, we can really see that the hills are much more prominent, and this just makes it a lot easier to understand the surrounding landscape. So as we can see, we've got a massive hill here as well as on the side, which is creating this big sort of basin. We've also got this ridge right down the middle, and that explains why that area isn't at risk of flooding. And it's all leading into this really, really flat landscape. I mean, this is an exaggerated area and it's still so flat. So it shows you just how flat this area is, and that's why it's at such risk of flooding. So overall, this is a really good way to just get a different perspective on your data and a really good understanding of, seeing something in 2D perhaps isn't always the answer. And by taking it into 3D, you can really get a better understanding of what you're looking at and can provide a lot more insight. So next, we're going to be looking at how to engage our audience by converting our 2D data into 3D. And for this, we're going to be looking at earthquakes. So we're going to go ahead and grab our data from the Living Atlas. And yeah, if we search earthquake, we're then going to be using the UK modern earthquakes dataset. So once we have that in and loaded, and we can see that it's not really in the symbology we want at the moment, but that doesn't matter. And also it's in the 2D layer subset, so we need to move it to the 3D layers. And once that's moved, we then need to sort out our symbology. So we're going to go to the Appearance tab at the top, choose Symbology. And instead of proportional symbols, we're going to choose graduated colors. We now need to make sure that we're showing the right field. So we're going to choose magnitude. And we're also going to change the classes to 10 just to give a larger scale and better show the spectrum of the magnitudes. So this data isn't in its final state yet, and it's quite hard to view. So what we want to do is we want to extrude that data to make it really stand out. So we're going to choose base height, and we're going to choose the height is going to be based off the magnitude. And at the moment, it's not showing much because we've got meters, and obviously that's too small. So we need to change that to kilometers. And now, as you can see, we can see it a little bit, but it's still not quite high enough. And we could do with it being bigger. So we're going to use the expression. So this is using our arcade language. And for this one, it's very simple. We're just going to use times 10 just to make the magnitudes stand out a lot more. And as you can see now that it's loaded in, we can see that it's a lot higher, and we can now start to interrogate this data, and we can pan around the data. We can have a look, we can see which are the higher peaks. We can zoom in, we can work out where the highest earthquakes have occurred. We know there's a lot over here in the northeast. And again, yeah, we can easily see the tall peaks, and it's just a really easy way of having the color visualization as well as the height to really understand our data and work out where these earthquakes have happened. So finally, I'm going to be showing you how to create a 3D hex bin and bring it into scene. And this will be looking at retail points. So we're going to go to the Living Atlas again, search retail, and we're going to choose geolytics retail points. So in this example, I'll be showing you how to turn this data set into a hex bin to then share it to online, pull it into an online scene, and create a 3D view. So before we can start, we also need a few more layers. So to create our hex bin, we're going to need a layer of the UK. So I have a countries layer here that I'm going to pull in. And if we untick the retail points, we can see that this just includes the whole of the UK. And we need this to generate our hexagons for our hex bin. So we're going to go to Analysis and then Tools. And first one we need to use is Generate Tessellation. So we have to choose the extent. So for this, we're going to choose the countries, and we're going to choose a hexagon shape type. And for the size, we're going to use square kilometers. And for this example, I'm going to use 25. However, you can use whatever you feel suits best. So if I run that, we then have this tessellation, and this is, as you can see, it's the hexagons, but we need it to be just for the UK. So this is where we need to do another little bit of analysis or use a tool. So we're going to clip. So we're just going to choose our input features will be our UK tessellation that we just generated, and we're going to clip it to our countries layer. So if we run this, we now have a clip that shows the UK as hexagons. And we now need to do some analysis to link this data to our retail point data. So we're going to use the Summarize Within tool. So the polygons that we're using will be our UK tessellation, and we're going to use the retail points as our point layer. And we need to make sure that we untick keep all input polygons, because we don't want hexagons for areas that don't have any of our points in. So we can go ahead and run that. And once we've done that, we have the hexagons that only have retail points within them. And we need to show this a bit better because it's not too useful at the moment. So we're going to go to Appearance, and then Symbology, and we're going to change it to graduated colors. And we want to show the count of points. So this is showing the number of retail points, retail locations within the hexagons. And we'll choose 10 just to show a more even spread of the color. So now we have our hex bin. We want to take it to the next level by visualizing it in 3D. So this is where, like my prior example, we could create a scene within Pro, but we're going to switch it up a bit and pull it into an online scene and show how you can visualize it in 3D using ArcGIS Online. So we're going to share that. If you right click it, sharing, and then share it as a web layer. So for this example, I'm just going to keep it as the name of the layer and add in my summary and tags. And we want to choose it as a feature layer, and I'm gonna put it in a folder. So wow, now I'll press publish. So now that it's been successfully published, we can go to Scene Viewer, and we're going to click New Scene in the top right and choose New Local Scene. And we're going to press Add Layers, and I'm just going to filter this to the folder that I added it to, which was our 3D visualization folder. And if we just press the plus, and now press Done. So now our layer is loaded in, but at the moment it's displaying as 2D. So if we click on the layer and then choose 3D counts and amounts, and this will extrude our layer into 3D. And first off, we're going to choose a color scheme that we like. I quite like this orange one. And we also need to change the height, because at the moment it's all set to the same. So we're going to change that to one of our fields, which is the count of points, which is our number of retail stores. And the height we're going to change to miles instead of meters. And now it's similar to how we were viewing it in Pro, but now it's in 3D. And I'm also going to change the scale here because I don't like the way it's showing currently, and that makes it a bit easier to pick out the high points. And if we want to, we can also, I like to add some edges. So I prefer to add the thin edges, and it just gives it a little bit more definition and separation between the different areas. So once you're happy with that, you can press done and done again. And if you want to, we might want to change the base map. So if we go to the top right and choose base map, I'm going to choose a darker one because I think it will go better with the color scheme. So now we have our data in a couple of minutes. We've taken it from Pro. We've made it more easier to view. And also we now have a 3D visualization of that data. And it's a lot more engaging, and we can get a better understanding of the breakdown of the stores across the UK compared to if we were just looking at all of that point data. To summarize what we have looked at today, viewing your 2D data in a 3D scene can provide further insight and can make it easier to visualize, especially if you are trying to understand the impact of the surrounding landscape. Also, it's always worth considering if you could convert your 2D data to 3D. It can make your data easier to explore, whether that's in ArcGIS Pro or an online scene. Once you know how to do this, it's relatively simple but can have a big impact on your data. Thank you for listening. I hope this talk has shown you the opportunities that 3D visualization can offer.